All right. So this session is called Student-Centered Computing Beyond the Name. The presenters will include myself, Doug Edwards, who is a Senior Research Associate at CEISMC. My background actually started in electrical engineering, and then I became a high school math, engineering, and computer science teacher. Also did a short stint as a college information technology associate professor, and I have been at CEISMC for the past 11 years, writing curriculum and doing teacher professional development. And Macoya?
Hi everyone, I am Makoya Bates. I currently teach computer science middle school in Clayton County. I am also the lead for the district in middle school computer science, as well as I've been working with Doug for the last 3 years on this with seismic, with capacity and whatnot.
And Philip?
Hello, everybody. My name is Philip Peavy, and I am a high school computer science teacher at Public STEM High School in Gwinnett County Public Schools. I just finished my 7th year of teaching computer science, 9th year of teaching, and I've been working with Doug and Seismic through GIFT for the past several years. I think it started in 2019, so really excited to show you everything that we're doing.
All right. So, student-centered computing, as we call it, started from a National Science Foundation grant we received at Georgia Tech called Capacity, which is an acronym that stands for Culturally Authentic Practices to Advance Computational Thinking in Youth. And as you can see, our primary goals were focused around actually the IDT course for the state of Georgia, and in doing so to promote the learning of computational thinking and increase the number of underrepresented students who enroll in later computer science courses. Our research outcomes, because we received that grant in 2016, by 2019 and 2020, our outcomes were showing significant increases in computational thinking for all students, regardless of gender or race and ethnicity, as well as a statistically significant increase in student cognitive engagement, as well as their intention to persist in computing. And so Capacity was designed as a project-based learning curriculum. It had 4 culturally authentic practices, which you see here, and that I will go into more detail in a few moments. And we also wanted to, of course, focus on improving computational thinking. From Capacity, we made changes. We dropped the science cross-cutting concepts, except for the one on patterns. So there's still a slight focus on the idea of patterns in the curriculum. We align these standards to the new Introduction to Software Technology high school standards for high school, and maintain the alignment to the standards for the 2 middle school courses, which you'll also see momentarily. And we also changed our projects for a better progression into IST in the middle school courses, added scaffolding in year sketch and Thunkable instruction, and all our app projects in both the middle school and high school curricula use Thunkable, and most of them use year sketch. And we are now, in addition to being supported by National Science Foundation, supported with funding from Google. And so in the transformation, we kept the culturally authentic practices because we find that they, by their own way that they are designed, center students in the curriculum. And We begin by explaining that our view of culture is broader than the common view, where, as you can see in this iceberg, people tend to look at what's on the surface. So the music a group listens to, the language they speak, the foods they eat, sometimes their festivals and holiday customs, how they dress. But we're looking beyond that to values, body language, gender roles, their notion of self, notions of modesty, thought processes. And you can see that what crossed out is learning styles, because the research has shown that what most people think of as learning style actually shows no significant impact on learning. So when people say, I learn better from hearing or from seeing, um, studies have shown that doing work that focuses the student around that actually does not make a significant impact. So we focus on involving the whole self of the student as a part of this curricula. And with that, we want them to bring themselves into this curricula. In so doing, we have students at the very beginning of the curricula pick a problem that is important to them and that they have a personal connection to. And in so doing, they are then able to advocate for that problem through websites, through games, through music, um, and by focusing on the skills and knowledge that are needed to do these creative projects. And then we also focus on reducing their potential negative stereotypes with respect to that, as well as creating collaborative space for equity in particular, because students collaboratively manage the projects, and they actually in the same project will actually rotate their management roles so no one is stuck in the role. And for teachers, we have students having specific roles so the teachers can hold students individually accountable within a group project. In terms of those culturally authentic practices, by students choosing and bringing themselves to a project and doing research and sharing ways to solve it, as well as coming up with their own ideas on solving that problem, we impact student agency for the better in terms of asset-based thinking. By sharing their personal stories, we ask them to bring their personal assets of who they are and their lived experience into the project. You'll see an example in a moment of how we address social identity stereotype threat. As well, we already talked about collaborative learning. And the culturally authentic practices are slightly different from culturally relevant pedagogy. We still have student achievement using balanced measures because, as you've heard, we have students focus on projects, and in so doing, teachers can easily take what we call the student check sheets and make rubrics out of them, or they can go ahead and design multiple choice assessments if they want to. We also, in terms of students' cultural competence, we have them bring their funds of knowledge. That's bringing in their personal stories, be it in language, heritage, or any other lived experience they want to bring to the problem. But from a socio-political awareness standpoint, we afford that, but we don't require it. So what we found over the past few years is that many students, the majority of the students, tend to choose problems that deal with mental health awareness. Everything from bullying to feelings of anxiety and depression. But they also cross the gamut into projects that deal with college debt, as well as you will see other projects when Makoya and Philip share what some students have done. And so, in terms of addressing stereotype threat, one of the things we do in student-centered computing is we do a little end of unit game called Who is a Coder? So we have the students in the chat. First, they just look at images of a diverse group of people, and we ask them to tell us how many they think are coders of the 6 people who are here. And then after they all fill in the chat, we give them a hint. So we share where these people went to school. And you can see they are from various universities across the country. And then we have another hint, who's their employer. And so sometimes after school, most students start to figure out who is a coder and who they may see as not. And then after we share who their employer is, we share a career hint. And last but not least, we share their name and what they do, and allow for the discussion to open up in terms of what makes a coder a coder. We do this at the end of 2 units in the curriculum. And then in the 3rd unit, we ask teachers to take a picture of their class. And when they show that first slide asking who is a coder, they put images of the class up so that we know it's worked if when they show their class, they actually say that we are coders. And one of the things we also have them do is they share a 2 to 3 minute video on one of the people that are in the slides. As well, we address social identity and stereotype threat through growth mindset. As students finish each unit, they develop a resume and share what they've learned on their resume to show that they are becoming a coder because of they're applying coding. So they're becoming a coder. We also share college student video shorts where they share what interested them in computer science and what obstacles they may have had to overcome. These are, once again, 2 to 3 minute videos. And we talk about representation in gaming, particularly around gender and ethnicity as well. The platforms we use in the curriculum, we suggest that Google Sites is used. It's free. There are no downloads, but teachers sometimes use Wix or other platforms that they choose. For music, we have them use EarSketch because you can code music in Python or JavaScript. For the middle school and our first high school course, we suggest Python because the syntax is easier. As you can see, EarSketch has over 4,000 sound loops developed by Jay-Z's audio engineer and a synthesizer composer who actually lives in Georgia named Richard Devine. Our curriculum is aligned to CSTA standards as well as Georgia standards. It's used in multiple curricula. And now EarSketch actually has a language toggle button for Arabic, French, Hebrew, and Spanish. And as we said, it's free and runs in Chrome, Safari, and Firefox. EarSketch also does yearly competitions where students can remix celebrity sounds. And each year a new celebrity is added. So as you can see, Sierra, Common, Pharrell, Jay-Z, Alicia Keys, and Khalid. Also, I don't have them on here, are celebrities that are in there. Next year's celebrity will be a Latinx artist that is very well known, but I can't share who it is. I've been sworn to secrecy. With Thunkable, right, you actually use block code to make mobile apps. You can upload images, animation, sounds. You can share your app with others as a link, or you can share it so that they can actually put it onto their phone. It works for both Android and iPhone. And once again, uh, in our curriculum, uh, everything you would need to use is in the free version. There is a pay version as well if you want to do much more extensive things. So I'm going to turn it over to Macoya so she can talk about our middle school curricula. And Macoya, you're up.
Okay. So with the middle school curriculum, we have two, the middle school foundations of programming, which aligns with the seventh grade computer science curriculum for middle school. And the projects that we actually do using this curriculum are problem research and selection, ear sketch, coded music, based on the research facts, Thunkable, with mobile app and the microbit piano. So throughout this actual curriculum, we actually we start out by having the students just think of problems that actually affect them in society or personally. For example, some of the actual topics that were big in my class this year were things like cyberbullying, some things like overthinkings, which are like interpersonal things, and just safety in general. After we actually go through that problem selection, we go through a process of kind of grouping the project so the students can form teams. The teams aspect is in conjunction with those foundational skills, and it helps the students to start to collaborate as a team because just like at our job, it's necessary for them to collaborate to complete a task. After they have been grouped, based on that problem, they actually go to a phase in which they start to research. And with this curriculum, everything is as far as the supporting resources to assist them on how to research and things of that nature are actually um, outlined. So they go through a process of researching. Once they are done researching, then they actually move to music. App and website design, which is more so with that interactive design, which is the next one. So, kind of similar with the actual the seventh grade. So the seventh grade, the main focus is building that foundation of computer programming. So that's why we're focusing on that last one on programming with the app and with the ear sketch writing in Python, helping them to understand that syntax. So with the interactive design, um, that's where we actually extend and we start to, like I was just saying, with the problem selection, the website, and then we actually create a thunkable quiz game that assesses that students are actually able to play in order to showcase some of those facts that they actually spotlighted on their website. So again, some of those hot topics are on the right, and like I said, coming back from a year where we were all online, the students were able to not just do this in the class this year, but they were able to complete this online. So it gave them multiple opportunities, provided them with a lot of resources to actually create their website and that app. Um, so they actually go from problem selection, research, website design, and then to Thunkable. where they incorporate that ear sketch.
And to talk about our high school curriculum, Philip.
Yes. So, to preface everything, I had taught computer science for about 4 years before I really got into um, the CEISMC capacity curriculum, now student-centered computing curriculum. And so I always taught it like just basically like you would any basic class of just going through the material. It was, I mean, I did well, the students did well, but they weren't as engaged as I would like it. And a lot of the times the kids were like, hey, this just isn't really like, are we ever, like, how would we ever use this in real life? And so, really, when you look at the student-centered computing curriculum and the focus and the overarch theme, it really does tie it into natural ways that you'll use computer science in real life. And so, the way that high school really differs in this case in the curriculum is you see that, again, the same thing. They do develop their ideas and coming up with ideas. And this is great because it's usually at the beginning of the school year when you're still getting to know your students and you really get to see what are some things that they actually are interested in. So really it helps me as a teacher be able to know like what are my kids interested in, but then also for them to kind of share with me several ideas that they like. And so really getting them to brainstorm about what's going on in our community, what is some things that we might want to change. Kind of like Macoyia was saying, you're going to get a wide variety, and it depends on the year what's happening in the world and what's happening with the students. I do know like some teachers are always like, but what if they decide to pick a very controversial topic? And my biggest thing is just always making sure that it's fixing a problem that they would like to see, and bringing it back to that idea. And so really getting them to brainstorm, getting to think about ideas of how they can voice that, how they can encourage other people. And this is also a fun way that if you know somebody that is doing stuff like this in your community, getting them to be a guest speaker. I actually encouraged one of my coworkers to actually do that when he was doing something like when he was actually kind of doing a project like this, where he actually got someone who kind of helped develop an app and actually got him as a guest speaker on Zoom. And it was all about like finding food shelters in our community in Gwinnett County. And so it was really cool to have that. And the kids were like, oh my gosh, I saw his app was on, I think, Doritos bags. And they're like, what? And so it's really cool to be able to do that and tie it in. But then going from there, teaching the kids how to make a website. And I know some people are like, well, we do web design and Google Sites is kind of not the best design. That's where this is really good because sometimes if you want to go more in depth with web design, you can do that. If you don't have that pathway as much at your school, having the kids work together to make a Google site over a specific issue, and then going into one of my favorites, which is Ear Sketch. I have used this now for several years, and it's really fun because honestly, anybody's song can sound good no matter how good of a programmer they are. And it really teaches them some really good skills on making an actual song. It brings in the artistic part. So you get kids who might not engage typically with technical issues, but they like the artistic part. And honestly, it's just one of those things. It's very great for being able to work with sounds. It helps bring in like actually understanding why you would use a loop. And like there's so many different things. You can incorporate lists into Ear Sketch and making music with a list of tracks. I've had some kids actually make a jukebox where they actually had different songs they were able to pull in based off, or make your own song by having people input like what they want to do. And so really, Ear Sketch, you're teaching them the basics of programming, you're getting them involved with it. And then lastly, it's, hey, we're going to actually make a song, but make it actually for our app or our game that we're going to make in Thunkable. And so really being able to actually make it very meaningful where they're actually making some sort of product that they can display. And really what they're making in the ultimate deal is a website portfolio of something that they've done all year long. And really what I've seen with this type of curriculum and with this structuring with the ARC is that you're preparing your students for not just APCSA, but real life work where you're working on a project that's going to take more than just 1 or 2 weeks. You can obviously you focus on it too much, the kids will get a little like, oh, this is a lot. But you like through a whole entire year, you can go do off various different paths, go into different unit. If you want to do a unit on the parts of computer, new emerging technologies, you can do stuff like that. But then also like coming back to this, like it's something that happens all year long. It's a year-long PBL. And that's the best part about it is that it gets the kids really to work on something long and they become very, very proud of what they do. And so that's where, and I've seen kids who've gone through this curriculum at my school that I taught do successfully well in all their past computer science classes. And actually, a lot of those kids continued on in computer science after back then was IDT, their IDT course. And so that was a very cool part, just being able to use this. And again, like the ARC and the way it's structured is a very big project, but then also at the end of the day, it's a meaningful project that the kids get behind. And like I hear a lot of my students who I didn't teach that had a different IDT course and they did a more traditional fact, like, oh, I hated doing that project. But then my kids like, oh, I liked mine. Like we made songs in Sketch and we made an app. And like I wish I could have done that. Like we just did this project where we made like an animation about this. And I was like, and so or we did this thing with moving a dog around the screen. And that's just one of those things where like the kids had more fun, they learned a lot, and they didn't even realize like they learned functions. And so that's kind of a fun part that I really liked about this. And if you go to the next slide, this really does cover all these standards for IST and beyond, and you can really manipulate it to however you'd want to do it. And that's the great thing. So like with IST, there's so many different pathways that can come out of it. If you have game design at your school, you can really focus a lot on Thunkable and making a game. If you have web design, you can focus more on the web design aspect. If you have more just a regular programming part, you can focus more on your sketch songs and also Thunkable as well. And so that's where it's one of those things where there is an ability to be able to kind of focus on certain things that you like more to fit the standards how you would like it too. But then also, again, the biggest thing about this is I've seen some teachers go through where they do the standards one by one in the unit, and that's not this. This really shows that, hey, all the standards really work together and you're building upon it every single iteration as you're going. You're not going to be able to teach, like you could teach Scrum and Agile as a software development process, but until you actually showcase the kids how we're actually using Scrum and Agile, that's a different story. Again, you can do a storyboard activity, but until you actually have the kids actually make an app where they're storyboarding or making a song and storyboarding the song, that's a different type of it's a different experience. And that's one of those things that really kind of sells this and really is very beneficial for the students and getting them to actually be a part of it. And I guess we're going to show you some examples of what some kids have done in a second. So, Doug, do you want to take this?
So these are examples of websites that students have done in Google Sites, just to show you once again that range. These were done actually a few years ago. So as you can see, the types of images they choose in terms of the impact to engage, and then in terms of the coded music examples, you can see Ear Sketch on the right, and in terms of the code, similar to what was used. So for car accidents, you can see they slowed the tempo. And they actually had a sound effect in about another 10 seconds. Whereas for anxiety and stress, these students actually decided that they would have more upbeat music so that the person who has anxiety and stress might feel better as they view their website. And with ocean and marine pollution, they decided to start with what's called a riser sound, because they said it kind of represented the sound of waves to them. And so there's a scaffolding that is done around music and mood that helps students understand how to select tempo, how to select pitch. They learn how to make their own beats, and so on in ear sketch. Whereas in Thunkable, and we actually used to use App Inventor for IDT, so the screens you see here are for App Inventor. But you can see on the left is the ocean pollution app. So they had the shark go around and grab the items that were polluting items. And in the school shooting app that was done actually 3 years ago, the player role was to take the students into a safe room that had been defined already in the school in this scenario. And so in summary, you can see the quotes here by teachers, administration, and a student. These are just a sample of the many quotes we have that tell how important this idea of student voice and choice is, and students bringing themselves, becoming invested and engaged. And that, ladies and gentlemen, brings our presentation to an end. And if you have any questions and want more information, please contact me at doug.edwards@seismic.tech.edu. So thank you very much, Macoyia and Philip. Any parting words?
Well, I'll just say it's a great curriculum. It allows the students that voice and choice option, and it allows them to gain those equitable opportunities out there in computer science. So definitely a great curriculum to use.
Yeah, really just echoing that. I mean, it's one of those things where, and I saw that last slide, and I was like, oh, I think I might recognize that student. um, and it's one of those things where a lot of the kids who I've had that have gone through this really actually do see themselves at the end of the year being a computer scientist and seeing themselves, even though they might have started the year not focusing on that, really wanting to continue on in the pathways. And to this day, we'll say that student, she's actually looking to go to become a cybersecurity specialist now. And so it's one of those things where, like, just because they took something like this course, like when they're either in middle school or freshman or sophomore or even junior in high school, and being able to kind of go further past that and really make a difference, and learning how to make a difference in their world is the biggest thing. Because that's what they're doing, is learning how to find an issue and how to fix it in society.
Well, thank you both very much. And thank whoever ends up viewing our presentation. Have a great afternoon.